Hi everyone. So in this video, we want to look into some complex unit conversions involving density, molar mass, molar volume, moles, molecules, atoms, and then the volume under STP condition. So I've made other videos before that was going directly from moles to either like molecules or atoms, or from moles to volume under STP, or from moles to grams using molar mass. However, this particular video is about multi-unit conversions that it involves kind of somehow all of them together. So let's take a look over here. This was a chart given before as well. So from this, by looking at this chart, you can see you can go from moles to basically different units, including molecules, atoms, or you can go to the grams, or you can go to the liters for gases under STP conditions. So this is pretty much the what we're using over here, but we're actually doing multiple unit conversions. So we're not just doing one step, it's actually involving multiple steps. So let's take a look over here. So the first question says, how many molecules are there in a flask containing 50 milliliters of NH3 gas under STP conditions? So the volume of the gas is given to us. However, it's not in liters and it's in milliliters. So first step for us is to convert milliliters to liters. Then that means we're in the orange box right now. Then we have to make it to the moles, which is the red one. Then we have to go to the molecules on the right, which is the cream one. So basically there's a few steps we have to go over here. So let's start right now. So we start with what the question has given us, 50 milliliters. Next step, we have to convert milliliters to liters. So milliliters can cancel out. Then next step for us is to go from liters to moles. So liters has to go at the bottom, moles at the top. And then using the molar volume of gas under STP, we know for every 1 mole of gas is 22.4 liters. So as I said, for most of my videos, I'm going to be using 22.4 liters for the molar volume for under STP condition. However, some textbooks, they define STP as at a different pressure. So that's why they might use 22.7, but the calculation is pretty much the same. It's just that instead of the 22.4, you have to use 22.7 instead. So this way liters can cancel out. And the next step for us is to convert moles to molecules. So moles has to go at the bottom, molecules at the top. And using Avogadro's number, we can find the number of molecules. So this would be our final answer. Now let's take a look at another example. What is the molar mass of one molecule of anthracene having a mass of 2.96 times 10 to the negative 22 grams? So molar mass is one of those things that it's made from 2 units. So it's best to write the unit for that. It's not one of the units that you can't use unit conversion to find the answer for that. So it's best to actually write the formula of molar mass, which is grams over moles, and then see which information is given to us in the question. So the grams is already given to us, so we know that, but the mole is not given. Instead, they gave us the number of molecules, which is 1 molecule. So our step is to cancel molecule and convert it to moles. So molecule has to go at the bottom, moles at the top, and using Avogadro's number, we can find the number of moles inside anthracene. So this way, this is the number of moles. And now we know the grams, we know the moles, so we can simply divide these two numbers by each other and we can find the molar mass, which would end up being 178 grams per mole. Now let's take a look at another example. It says, what is the density of acetic acid, CH3COOH, if 0.250 moles of it has a volume of 14.3 milliliters? So density, same as molar mass, it's made from two different units. So the formula for density is mass per volume, so it's grams per milliliter. Generally speaking, density is given for the volume, it's given in milliliters and not liters, so we stick to that right now. We have to see what information from these two we have, which is the volume, which is 14.3 milliliters, so we have that. But then for mass, we don't know the mass. However, we know the moles, so we can convert the moles to grams. So to do so, we have to use molar mass. So we know for every 1 mole of acetic acid, there's 60.06 grams. We can simply add the numbers up and find it from the periodic table. This way, moles can cancel out and we get the answer in grams. So now we know the grams and we know the milliliters. So we can divide these two numbers by each other and we can find the density in grams per milliliter, which ends up being 1.05 grams. Let's take a look at another example. What volume of C6H6 contains 8.50 times 10 to the 24 atoms of carbon? And then the density of C6H6 is given to us in grams per milliliter. So here we have the number of atoms within a molecule of C6H6. So we know there's this many carbon atoms within one molecule, within a molecule of C6H6. So first step for us is to convert atoms to molecules. And then we have to go from molecules to moles using our chart. And then we have to go from moles to grams. Once we get to the grams, then we can use the density, because you can see the unit of density is in grams per milliliter. So you can then play with the density to cancel grams. And that way you can get the answer in milliliters first. So let's start with that. So we start from 8.50 times 10 to the 24 carbon atoms. Next step is to find the number of molecules from the atoms. So we know for every one molecule, there's 6 atoms of carbon. Carbon atoms cancel out. Then is to go from molecules to moles. So molecules has to go at the bottom, mole has to go at the top. Using Avogadro's number, we find the number of moles. These two can cancel out right now. And then, as we said, we have to go from moles to grams. So we have to use molar mass. So mole has to go at the bottom, grams has to go at the top. For every 1 mole, the molar mass of C6H6 is 78 grams. So moles can cancel out. And now up to here, the answer is in grams. However, we want to use the density to get the volume. So the unit of density is grams per milliliter. So this time we have to make sure to cancel the grams. So grams has to go at the bottom, milliliters has to go at the top. And this is like a ratio thing. So we can say for every 1 milliliter of C6H6, there's 0.877 grams. So this way grams can cancel out and we get the answer so far in milliliters. However, because the question is asking us to find the volume, it's best to find it in liters, because liters is the standard unit for volume. So next step for us would be to convert milliliters to liters. So this way milliliters can cancel out, and this is our final answer. Let's take a look at another example. Here it says find density of gaseous ethane, C2H6 at STP. So for this question, there's no numbers given to us. So we have to think about what we know about C2H6. And the only information we have about it is its molar mass, which has the unit of grams per mole. However, the density is usually in the unit of grams per milliliter. So we have to somehow go from grams to moles, grams per mole, and convert it to grams per milliliter. So we start with the molar mass that we know for C2H6, 30.08 grams per mole. And then we want to keep the grams because our final answer has to have the grams in it at the top. But instead, we'd want to get rid of the moles at the bottom. So we have to convert that to milliliters somehow. So the fact that we know it's at STP helps us to convert moles to liters under STP. So we know for gases, for every 1 mole, there's 22 liters under STP condition. This way, moles can cancel out. And so far, our answer is in grams per liter. However, we want to, again, convert it to grams per milliliter. So liter has to cancel and can be converted to milliliters. So liters goes at the top, milliliters at the bottom. And then this way we find our final answer in grams per milliliter. Let's take a look at another example. What is the molar volume of quartz, SiO2? And the density is given to us to be 2.64 grams per milliliter. So molar volume, we have to first figure out what is the unit for molar volume. So molar volume is in liters per mole. And the information we have is in grams per milliliter. So that's the density we have for it. So the thing is, because we want to have the unit of volume eventually at the top, right now, what we know for density is that the unit of volume is at the bottom. So we have to kind of switch the top and bottom with each other. So I have to start writing for every 1 milliliter, there's 2.64 grams. It's just basically a ratio thing. Not like value-wise, it's not going to make a difference. Still, we're saying 1 milliliter is 2.64 grams, or we can say 2.64 grams is in 1 milliliter. But however, it's best to start with a number, the volume at the top, and then the grams at the bottom. So we start that way. And then second is we want to convert milliliters to liters because our final answer should have liters at the top. So this way we convert milliliters to liters. And then next step for us is that to get rid of the grams in the bottom and instead convert that to moles. So to do so, we have to use molar mass. So grams has to go at the top, mole has to go at the bottom. And using molar mass, we know that for every 1 mole of quartz, there's 60.1 grams. So this way grams can cancel out. And then we end up getting the final answer in liters per mole. All right, so that's it for this video. I hope you liked it. You can subscribe for watching more videos. I'll be posting regularly. Thank you. Have a good one.